Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week for round two is Wolfgang Kampichler, Principal Scientist at Frequentis AG, and Gabriel Unterholzer, President and Software Engineer at DEC112. And last time we spoke, we met and discussed what enhanced 911, 911 services are and what they could and how they work, especially in Europe. So first of all, thank you for joining us again today. Would you like to start with a quick introduction about yourselves so that we start the discussion? Maybe Gabriel first.
Yeah, thanks for the invitation. Hi, everyone. I'm Gabriel. I am the president and developer at DEC112. It's an NGO association in Austria, and our goal or target is to provide accessible emergency communication systems, especially for deaf people in Austria. And as Wolfgang is also on the board, at DEC112, we provide standardized emergency call solutions. So we really focus on that everything that we implement is harmonized and interoperable. And so that's basically wrap up what I'm doing and what we are doing at DEC112.
Thank you. Wolfgang.
Yeah. Hello, my name is Wolfgang Kampichler, and I work for Frequentis AG, an Austrian company in the field of safety critical communication and information solutions. And one of my tasks is standardization of emergency communication. And this is what actually brought me to ENA, NINA, and also to DEC112. Since standards are also something that needs to be implemented, we founded an association to promote the topic in practice. So actually we have a running system in Austria. And we are looking forward to today's session to present our work. And thank you very much for having us here.
Oh, thank you. I think it's the work you're doing, I think, is very, very important. And funnily enough, I'm from Italy, but I've done mostly my work has always been in the US on telephony. And so I'm used to the American standards, which have been there for a while. And while still rough around the edges, have been very helpful for people. So first of all, maybe we could start with Wolfgang. Could you give us just a quick overview of what standards are we talking about? Like, what's the purpose of the emergency services standards?
So actually, the main purpose is that since we have a change in technologies for communication, so if you do an emergency call, it's just a voice call currently, but there are a lot of other media types that we are used to work with or we are used to use, like video and text. And this is also something very important for accessibility. And in order to get that in every mobile device or other devices, we need standards. We need standardized interfaces that make sure that the media is understood at the origin. So at for instance, a mobile device and also at the PSAP side. And in addition to that, or besides the media part, we've also very important information for control rooms, which is the location. So in some situations, it's very important to know a very accurate location at the control room to dispatch resources very efficient and to get them to the site, to the scene as quick as possible. So this is also something that needs to be standardized because end devices know a lot about location, from your mobile device. And in order to understand that location object, so the information that is shared with the control room, it's also something that needs to be standardized. And such informations are also used to route to the most appropriate or most, I would say appropriate PSAP, but that's fine. And this is something that's quite interesting in Austria. We have 9 federal states. So if there's an emergency in Vienna, where I currently am, it needs to get to an emergency service in Vienna.
Nice. Well, I think again, that's very, very important. I know most of this research stems from the American standard. I don't remember the name of the standard, unfortunately, but it's about providing and up-to-date voice over IP information for every number, including location. So, well, Gabriel, this is all software. So I'm very interested, especially being part of the open source community, for the project and all the others What do you think? What first of all, what's your work about, and do you think it's a good? What's a good way to start integrating the systems into open source platforms?
So as Wolfgang has already highlighted, his work is mostly focusing on standards. There was no real implementation for it. And the idea in Austria then was to found an association and to bring the standard to life, and to combine a second use case. So especially for deaf people in Austria, for hearing impaired, it was very difficult to place emergency calls in an accessible way. And therefore, we decided to combine the standard and the use case of text-based emergency calling in Austria. So what DEC112 is currently providing is text-based emergency access to deaf and hearing impaired people. So basically, you download the DEC112 app, you register there with your telephone number, and then you can chat with an emergency control room via a chat interface like any messaging service. And we use this opportunity also to wrap all the communication, all the everything that makes the standard into an SDK that we provide open source. So basically, this is a JavaScript or a TypeScript implementation of the standard that can be integrated into web-based emergency call solutions, or also into app-based. Like we provide an Android app and an iOS app for the emergency call app, and this is under the hood. It is the SDK that powers the app, and in essence, everybody could integrate the standard because it's everything is well defined and publicly available. But of course, if you integrate the SDK directly, you don't have to care about how to transmit location, how to transmit personal data, because everything is handled by the SDK directly. So in essence, we want to make it easier for developers to integrate an arbitrary app into an NG911 or NG112 compatible system.
Good. So yeah, so the SDK is client side, correct? What languages have implemented it, and does it support? So it's SIP based, right? Which adapters does it support?
Exactly. Yeah. So it's implemented currently in TypeScript and compiled to JavaScript, and it is using SIP over WebSocket. So traditionally, SIP is always TCP based, especially for us as we are sending SIP messages. That's why we need the TCP part. And as it is used also in web-based implementations, we chose the way of WebSockets because WebSockets are very well supported in most web browsers, and which also makes it very easy to have this real-time communication. So if a user sends a message to the PSUB, to the control center, it will also be able to, of course, receive a response from the control center afterwards.
So how it works is the JS SIP or SIP JS adapters will add the location information to the SIP invite. How does it work?
So we are currently not using SIP invite, as everything is basically based on SIP messaging. And SIP invite is used if you have real-time media like audio connection or video connection. And we are going the SIP message path, which is because it is the easiest way to establish communication between two entities via SIP. You don't have a real call open that you have traditionally, but you have simple messages that are hold together by a unique call ID that is generated client side. And in this message, the body, of course, the message from the user goes there. So everything the user types into the message goes into the SIP message body, and also all additional call information like presence information. So location information is transmitted via SIP message. And also any additional information that is coming from the user, like a civic address, the name, a birth date or any other information that could be important for medical emergency services.
Understood. So it's using SIP message capital, right? The listing for the SIP message implementation. Yeah, that's
exactly.
That's a very good idea. Yeah, one thing that can to start elaborating what open source integrations, for example, FreeSwitch could do. I mean, this starts client side for sure because it's the client that knows where they are. But maybe there will be there's still a way so that, for example, a server like FreeSwitch could receive a call from a client and automatically manage sending the location information instead of having to go directly to the server. There's probably a lot going on there. So a question for Wolfgang. Since February 11th was a day 112 day, and I think there was a lot of good discussion around that. What's the adoption looking like in Europe in general? Because as you know, generally things in Europe only move if almost everybody starts doing it.
Yeah, actually, there was a huge change when comparing the topic to the years before. So when we started in Austria, I think it was 2015. Yeah, so that was new for everyone, and everyone was a bit skeptic about this new stuff. But now we have the system up and running for 5 years, and it looks like it was always here. And this also helped people to understand how to deal with this next generation emergency communication solutions. And to your question, there is now, let's say, a shift in considering this also at the legislation side and the regulation side. So regulators are looking into it. Emergency service providers or control rooms are asking for it. Yeah, it's kind of starting of a new generation, yeah, and this happening now. And I think there will be a lot of new implementations and a lot of new things happening within the next year. So, for example, we plan together with ETSI in Europe an interoperability test event in Spain, which takes place in September, and we invite not only emergency services or control room providers to join such an event, which was only done always done in the past. Actually, we're also inviting people or vendors that implement an IMS, for instance, so they could provide their IMS solutions to see, okay, does this work, and can we forward from a mobile device some location information or set up an emergency communication from a mobile device via the IMS, via voice over LTE towards an emergency center. So things are actually happening, and we at Frequentis, we always see, or we recently have seen a lot of requests coming from the customers. They are asking, okay, what is it? What can you provide as company? And thanks to the discussions that we actually started with our idea in DEC 112, I think people now understand what it means and are going to ask for it.
Nice. Yeah, I think I know how important it is to provide this, and there's a few known standard ways on the market that, frankly, I think this is the kind of thing you should be standardized, probably even written into a law, like you need to use a certain protocol or whatever. So let's hope that move forward pretty soon. So, Gabriel, another question. Say I am some kind of institution would like to start adopting the protocol. Is there a corresponding server implementation I could run internally so that I can receive the C112 information? Sorry, go ahead.
Yeah. So we always split the system into 3 parts, basically. So the first part where the emergency call starts is the client implementation inside an app or web app, whatever. So this is the first part, which is covered by the SDK, basically. So then the third part is the emergency control room, which is on the very other side to receive the emergency call, which is also based which is also integrated into the SDK that we provide. So the SDK provides the client side and also the server side on the emergency control room to receive all the emergency calls. And I think the most important part is the part in between part 2, which is the ESINet. It's called ESINet Emergency Services IPNet, which does the coordination of all emergency calls. So it originates from the mobile device. Let's say it has a GPS location attached to it. And the ESINet then decides where the emergency call needs to go. As Wolfgang has already said, in Austria, we have 9 federal countries, and emergency calling and emergency control rooms, they are spread around all the federal countries. So there is this ESINet that decides where the emergency call needs to go and is then routed appropriately. And the server implementation is basically based on a Kampichler SIP proxy, and Wolfgang did a nice extension for it that it can also be used as a routing proxy for the emergency services IPNet.
Is there a repository for? Sorry, go ahead.
And of course, the Kampichler is an open source implementation, and also the module that was provided by Wolfgang is an open source module for it.
Very good. So is there a repository for the server side component? Maybe we can add a list to, we can have a link to the video when this airs. That will be very.
All the components are available on our GitHub. So it's github.com/DEC112. And there we have client-side and server-side implementations for it. Of course, Kampichler is not in our hands, as it is a general purpose SIP proxy, but also the module, the extension for Kampichler. I think it's even in the main repository from Kampichler. Correct me if I'm wrong, Wolfgang.
That's part of the releases. I think since 5.4 or something. I can't remember actually.
So pretty much any organization would like to implement this as all the components. Then it's extremely interesting. So maybe a few technical questions. How did you settle on using the SIP message protocol and not something else? Because as you know, there's so many real-time queuing protocols that it's interesting. Just a technical question.
Maybe I can forward this to Wolfgang's question.
Yes. Yeah. Actually, the SIP message method is also part of the standardization, but it's used for non-human communication. So if you have, for instance, a sensor, or if you use the common alerting protocol, then message method would be the way to go. And we just decided, okay, this is the simplest way to implement. We don't have a media path, and we can provide a kind of WhatsApp-based chat communication to the user. This was one reason, and the other reason was because it was very easy to implement also on the control room side, because you have this message-based thing. You don't need to use real-time text, which of course is also part of the specification and will be in use in the future. And we are actually also looking into that, see how we can switch from just session-based or message-based to real-time text. But yeah, to your question, I think the answer is it was very simple, and it's still it is simple. I think it's called SIP simple anyway. So that was the reason, and we see a lot of advantages because you don't have issues with kind of NAT things, and you don't have to look at the media parts. So it's easy to implement, and it serves for the purpose.
Nice. Yeah. I think again, it was a technical question. I'm actually happy it's a standard protocol, because on the other hand, many people have ended up reinventing something, and then they have to go figure out a way to, and that sort of blocks adoption, because SIP message is supported by everything more or less that speaks SIP. So you can do your own relay, you can do a lot of things, and it will use standard routing. So for example, I'm thinking about signal wires. we have a global cloud that's effectively a super big Camilio plus other stuff that could just travel over it. So it is it's very resilient, pretty much always works, slippery twice, etc. Always gets there. It is very good. So question for the project. What are you looking for? Is there anything the open source community can do to help? What's the next step in adoption or helping the project?
I think the next step, as legislation is also pushing towards this, is like Wolfgang said, real-time text. Because by 2027, if I'm not wrong, European Union, there will be a law in place that enforces real-time text emergency access for everyone, basically, throughout European Union. And I think the ESINet that we have in place is already capable of routing this. I think it's now the issue to also get this working inside the control rooms, because the control rooms, they are very traditional. Usually they are just picking up phone calls, traditional from a landline. It was already a change to bring message-based emergency calling to the control rooms. And I think it will be also from a technical perspective, really interesting to have real-time media inside control rooms, because most of the control rooms in Austria are currently not attached via SIP trunk, but they are just using landline phones. And I think DEC112 is able to support them to enable real-time communication there.
So it will be interesting to try and build something around probably Camilio that has the ability to both receive the messaging and take a phone call at the same time, so that you can have the person on the line, maybe on the same web page where you're looking at the DEC 112 integration. And it's the kind of thing I like working on. So who knows? Maybe I can take a look. It's my kind of project. So it sounds really interesting. You mentioned legislation. What do you think is the timing for the legislation to move in Europe? What's going to happen when it gets into a law?
Yeah, actually, the timeline is already here. As Gabriel mentioned, that we have a date that in 2027 the control rooms need to support this real-time communication for accessibility. So the only thing that needs to happen is that this moves into national regulation or legislation. So member states need to look at it, need to adopt it, and need to implement it. So this may take some time, and there, it's usually such things are not a hard date. So there is some time still to implement and to adopt new technology and things like that. But I think the next 2-3 years will show a lot of new things, because we already have this as part of the mobile devices. So they have the capability, for instance, to do real-time text, to do SIP-based communication using voice over LTE. So it's just a matter of what's being allowed or enabled for the subscriber on the mobile network operator side. So that's another thing that needs to be solved for emergency communication. And then you have the domain of the emergency services. And here we need this specific routing that was mentioned by Gabriel, depending on the local model, how you operate an emergency service. Like you have a central one, it's different than compared to you have a decentralized, like in Austria with the federal states. And if you get that, I think we will have this kind of total conversation you mentioned, where you have an audio call and in parallel you could do texting as well.
So yeah, I'll ask a question that I don't know, honestly. I work on the application side of telephony, so some things I don't know. Currently, when you place an emergency call from your cell phone using the normal dialer, using the network dialer, is there any location information attached to the call or not?
That depends. So as far as I know, there are some devices that if they use voice over Wi-Fi, for instance, so if you have your native dialer, but you connect via Wi-Fi, then they have this enabled to provide location information. So sometimes it's there, but the big question is it used or does it arrive at the control room? And I think here it's not happening actually. But we have other solutions like advanced mobile location or ELS, I think that's how it's called, where the end device triggers an SMS to a national endpoint or location hub with the location information. And this is triggered by the emergency number that is recognized by the mobile device. So it's being enabled by Apple and Google in some European countries. And I think it's also in place in the US. But it's just in parallel. So you dial 911 and this triggers the phone to send location to a location hub. And from there, the emergency services can just, retrieve the location.
So, I think a big part of this is going to be integrating into IMS somehow.
Yeah.
It's the IMS-like services, because that's when it really starts getting interesting. One thing we could do quickly, though, is implement emergency calling applications like yours, maybe with real-time media built in, so that you can also talk to the other side in one thing. So, of course, having it on the carrier side. Let's go talk to carriers. We are friends with a few, and who knows what they're going to have to do it anyways, because as you know, the European Union is very slow until they become very fast.
Yep.
Takes 3 years to approve the standard, then it has to work by next Monday. So people who are not ready will have a bad time. It is very, very interesting and true. Maybe we could, Camellia is already part of some IMS stacks. So there is probably something that could be done there. We need to go talk to Daniel and the friends at the Camellia project to see what can be done. Cool. So I think this is really, really useful. And just curious, what information is being transmitted? We never talked about this actually. What information exactly is being transmitted when you're using the emergency services? Is it just location or something else?
Currently for DEC112 emergency calls, you mean?
Yes.
So currently, of course, it's the message from the user. Then we transmit GPS location that is directly derived from the end device, Android GPS or iOS GPS or GLONASS sensors. And the user, so this is then encoded in the standard is called PDFLO, presence information location. And then we also transmit personal information via vCard. So everything like name, birth date, addresses. And in addition, if it's available, we could also transmit civic locations that is entered by the user manually. And all this location information can be used for routing purposes. So, of course, GPS location is very easy to use for routing purposes, but also civic location can be used via reverse geocoding to do proper location-based routing to the most appropriate piece of them. And of course, the user can, in Austria, we not only have one emergency number, so it's not only 112, but we have a different set of emergency numbers like 144 for ambulance. And this information is also used in the process of routing to get to the most appropriate piece of, because not all emergency control rooms are handling all types of emergency calls here in Austria.
Wow, that's I think I was thinking of what else could be added, like in assistive messaging, maybe some kind of text to speech or speak to text could be useful. I'm already thinking about what else could be you could be doing. For example, I'm not able to make a phone call, but I can send a message. So maybe you could attach something like a transcription. Most devices have transcription on board now, meaning that they don't go out to the network to be able to transcribe. So even if you're in a region where you have little signal, you will still be able to get the transcription out and into the message, into a kind of payload. So that would be very interesting to look at. Even if it's not perfect, it's probably a very big help. Like I'm not able to type, I'm having trouble, whatever. I can click a button, say something, and then it sort of works. It's there's a lot that could be done there.
I think with accessibility tools, especially on iOS, you are already able to do that because you can just use your voice to type in text into the text field inside the app and then just send it. It would be very interesting, of course, to also have it read aloud if you get a message from the control room.
Yeah, that's. I mean, there's so many things you could do with that. It's really very interesting. Eventually, real-time video. Since you're doing real-time, you could escalate to video. Opposite flip side, if you have enough bandwidth, you could be using video, which is even better. At that point, you're seeing the person. They can even show you what's going on. I think for a first responder situation, will be very, very important. Say there's a fire, instead of having the person explain what the fires look like, where it is, and whatever, they can just show you. So here's the fire, and you know if they should stay. But for example, and I'll just digress for a second. In a fire, as you know, it's important to know whether you should move or stay where you are. And the wrong choice usually kills you. So sometimes you have to stay where you are, and sometimes you have to move. But if you don't know, you do the wrong thing, it usually doesn't end well. So it's that's really a very, very. Let's do this. Let's work on this. There's a lot we can do with FreeSwitch on the back end.
Would be very helpful information for the control room as well to validate what the user is reporting and what the scenery is really looking like. Because especially when it comes to car accidents, the scenery might be very confusing for the user. They are not used to it, to seeing something like this every day. So it could be a proof to the call center what is really going on and what the user is describing.
Yeah, especially during an accident, you're right. You never know what exactly people like. If someone is just sitting there, they might not be very hurt, or they might be very hurt, but you never know because you're not a doctor and you were in the accident, so you have a lot of stress too. So it's really, I think this is going to be one of the key applications of this goes into the 5G discussion, really. Like we are moving computation to the edge, so we're able to manage much more computational data at the edge, process that and send it over. So you could connect to a 5G cell with then relays over its backhaul, which is much, much better than what you can do directly from your cell phone to the cell tower. And there is plenty to do there. I'm meeting with some guys at a couple carriers over the next week for unrelated reasons, but I'll have this at the end of the call for sure. Yeah. It's really something that could be very, very interesting. We have a couple of larger European carriers we're working with, and one of them is doing a 5G initiative. So this could actually be a very good showcase. So let's do this.
And the good thing actually is that we with the standard, we have actually the baseline. We have the building blocks to create all this. So it, with SIP, you can set up multimedia communication, and that's actually the idea for next generation emergency communication, that you have audio, video, and real-time text for all the purposes you mentioned. Yeah, so it just needs to be implemented.
And I think what is great, you don't need to know beforehand what kind of media you will need for a specific call. So you can start with a phone call, and once the control room figures out, wait, I need more information, I can just ask to activate video in addition, or activate real-time text in addition to have more information available, or to even have a better user experience. There could be, we've already had responses from control rooms that text-based emergency call is also very well suited if there is heavy wind, for example. So they cannot understand people on the phone, and they will switch to text-based emergency calling because it is too loud. They will not understand them. And it's always good to have the choice to enable another media channel just ad hoc.
I haven't thought of that. It might be wind. It might be something that's very noisy. Say there's an accident at a factory, so there's machinery running and you can't hear. It's it is. It's effectively even though those features are born out of needs of deaf people or people with disabilities, they're actually very useful in general because it is it's a multi-channel communication, so it is extremely important. And I think this is a very, very promising. I need to think about a couple things we could do together. But that's let's get this. Let's get this moving because I think there's a space. So last thing, I couldn't find a link to the specification itself. Is that on your GitHub? Is there a link somewhere else, like what the actual payloads look like? That way we can put a link on the bottom of the video and people can just go take a look.
So it's definitely on the GitHub, and I think also on our webpage, DEC112.at. So there should be the links to the standards.
Okay, perfect. I'll go take a look. Well, thank you, Gabriel. Thank you, Wolfgang. I think it's a very, very interesting and promising initiative. And again, for the people who think they don't care, know that the EU moves slow until it moves fast. And when they move fast, it's your problem. So you have to be aware this is coming and take the necessary steps. It also helps people, so it's a win-win, right?
Yep.
Well,
and of course, it's also a lot of fun developing it.
Oh yeah, it's really interesting with the media and the various modes. You got to interact with carriers. It's a lot of interesting stuff for sure.
Yeah,
well,
definitely.
Wolfgang, thank you for joining us today, and Gabriel, thank you for joining us today from the DEC112 project, starting from Austria and moving to the rest of Europe with the protocol for first responders and communications with control rooms. And we'll have all the links at the bottom of the video. And thank you for joining us today.
Thanks a lot.
Thank you.
For the rest of the people, I'll see you next week. Goodbye.